So L of x raised to n will be given by np into L of x raised to n minus 1 varum. Now repeating this again, instead of n replaced by n minus 1, so you will get n by p. L raised to x minus 1 I can write as n minus 1 by p L of x raised to n minus 2. So you will get in the next step np n minus 1 by p, then n minus 2 by p L of x raised to n minus 3 varum. So continuing in this manner, so you are going to get n by p, n minus 1 by p, n minus 2 by p, etc. Last n minus 1 varum, that will be 1 by p, then L of x raised to n minus n ആയിരിക്കും വരിക. Okay, അപ്പം x raised to 0 varum. So that will be equal to, now here on the numerator you have n factorial by p raised to n varum. Now this is L of 1. L of 1 is equal to 1 by p. So therefore L of x raised to n is equal to n factorial by p raised to n plus 1. So that is the value of L of x raised to n. And now let us look at L of sin ax. So by definition, that will be given by integral 0 to infinity e raised to minus px sin ax dx. So the integral e raised to minus px sin ax dx will be, so we have this integral e raised to ax sin bx dx will be e raised to ax by a square plus b square a sin bx minus b cos bx plus c. So using this, instead of a you will have minus p, and instead of b you will have a. So you will get e raised to minus px by p square plus a square, then you will have minus p sin ax minus plus p cos of minus x is same as cos x, cos, okay, b minus a cos ax from 0 to infinity. So at infinity e raised to into term 0 out, and at 0, so it will be 0 minus, so at 0 e raised to 0 is 1 upon 1 by p square plus a square. So at 0 sin is 0 into minus a varum, so that will give you a by a square plus p square. So that is going to be the value of L of sin ax. So L of sin ax will be a by p square plus a square. So that's the Laplace transform of sin ax. And similarly, if you want to find L of cos ax, so we use the integral e raised to ax cos bx dx. So that is e raised to ax by a square plus b square a cos bx plus b sin bx plus c varum. So you need to find the integral e raised to minus px cos ax dx. So upon integrating, you will get e raised to minus px by a square plus p square, then minus p cos ax plus a sin ax from 0 to infinity. So at infinity, e raised to minus infinity 0 varum, minus at 0 you will have 1 by a square plus p square into minus p. So we are going to get p by a square plus p square. So therefore Laplace transform of cos ax will be p by a square plus e square. So these are some of the common Laplace transform. So L of 1, then you have L of x raised to n, L of e raised to x, then sine and cosine, and L of x raised to n edukumbo. So the result will hold for any n greater than or equal to 1. Okay, n is assumed to be a positive integer. Okay, we have L of x raised to n equal to n factorial by p raised to n plus 1. So n is a positive integer in this case. So these are few common Laplace transform. We'll see more problems in the next class. Thank you.